Good afternoon, everyone. Thank you all for joining us here at reInvent this year. My name is Tyson Lutz, and today I'm really excited to show you some amazing things that we're doing here at Salesforce for our development teams. Today, we're going to show you how we empower thousands of developers to innovate with more productivity than ever before. And so let me set the stage for you. We had a challenge. We had to provide thousands of developers an agile work environment, a representative Salesforce ecosystem that could be used for development and testing and empowers them to build in quality and optimizations throughout their service. So we're going to take you a little bit on a journey today. You're going to hear directly from our internal capacity engineering team about what we learned from our developers, the trials that we went through developing this service, and then the key takeaways for you to use on a similar journey. But nothing says productivity more than our forward-looking statement. And so remember, when making purchases, always base them on what's available today, and you can always check out more on salesforce.com. So let me ask you a question. What is developer productivity, and what does it mean to you? How does a company empower its developers to work in an agile workspace? For us, productivity means to empower our developers to do more and innovate faster in an ever-changing landscape of customer interactions. And so what do I mean by customer interactions? Well, right now is the most innovative time in technology's history. And to put that into perspective, billions of devices and interactions and products are being connected on the internet. And behind each and every one of those interactions and product and device is a customer. Worlds of opportunities are being created daily, and customer engagement is the new currency that make businesses successful. We are truly living in the age of the customer, where each and every touch point is intelligent and connected. Every industry is being disrupted. And as we become more of an integral part of a customer's IT infrastructure, the trust of our customer is more important than ever. And so for us, to stay ahead, innovation is paramount. And because these trends move fast, interactions change quickly, Salesforce needed to be agile in the developer space to stay ahead. We must provide tools for our developers that allow them to create at a sustainable pace, build value into our product, and deliver trust while optimizing for a whole ecosystem. We have 3 feature-rich releases per year. We have 6 billion lines of Apex code, 12 million Visualforce pages, and we generate over 600 million API calls per day. This is not a small ecosystem. The need for our developers to experience our ecosystem at their fingertips drove the innovation you're going to see today. When developers can see the entire ecosystem, test and validate iteratively against that ecosystem, you allow these teams to work closer together. They can make accurate shifts in service development more quickly. They can move tighter in the same direction and deliver on time with the highest level of quality and trust. We empower our developers to blaze new trails together. And so let me take you back a few years ago. Product teams wanted the ability to perform performance validations iteratively, allowing for fast repeatability across services. Now, only so much could be done at their desktop, where building the entire Salesforce ecosystem was nearly impossible. We also provide sustained development services as well, but that didn't scale with the ebb and flow of feature development through an ever-growing community of product teams that we had. So a lab had to be created that was representing the Salesforce ecosystem, both in features and in services, to help fill that gap so that teams could get better insight into the overall functionality of their service. And to keep up with our developers, we didn't just have to turn up tens or even hundreds of labs, but we had to turn up thousands of labs a month. And so now, to take you on that journey, I'd like to introduce Varun Gupta, Director of Engineering, leading our test lab efforts at Salesforce.
Thank you, Tyson. Hi, I'm Varun, and as Tyson mentioned, I'll be walking us through what brought us to create this environment platform and the phases we went through to reach where we are today. So back in 2013, we had a scenario where developers were lining up to get access to development environments. They had to use these environments to run their performance workloads, to run their performance tests, to test their functionality in an environment which was representative of Salesforce ecosystem. However, the way we were doing this was a developer or a team would go and test on the environment, and then they will pass it on to the next person in line. However, we couldn't just have the next person go ahead and use that environment. We had to bring it back to a known good state, and we had to make sure that it was set up correctly with the data set for the next team which wanted to use it. And that added sometimes days of time lag before the next team could come in and use the environment. And that led us to start looking into what were the issues. Did we not have enough resources to serve the demand of the developers? Well, we had several hundred environments for a few thousand developers. That ideally should have been enough to serve the needs of the teams that we had. So we went deeper. We started looking at what were the key challenges that were preventing us to use these environments. And one of the key things we realized was underutilization of the environments we had. Once a team would get an environment, they would want to keep it until they had run all their tests. And in some cases, that meant a few days of not doing anything on those environments while the environments were still sitting with those teams. And of course, we had a lot of manual processes and human involvement in getting these environments from one team to the other. We had sharing challenges, and we also had challenges on bringing an environment to a known good state because we were recycling the same machines. And then we thought we should also ask the developers, what are they looking for really in the next generation environment platform? So we went to our developers and asked them, what do they really want? And here are some of the keywords that came up. As you can see, one of the big ones was self-service. The developers wanted an ability to bring up an environment when they needed it without having to wait on somebody to pick up a ticket. And guess when we were getting most of these requests? As a self-proclaimed night owl, we were getting most of our requests in the middle of the night. So developers wanted to be able to bring up an environment while they were working any time of the day, which would be really fast. It would represent the ecosystem. It would be easy to bring it back to a known good state. And there would be some flexibility into the configuration and setup they have on it. And of course, for our own sake, to reduce our operations, we wanted this platform to be efficient. And that led us to our mission of creating our own selfie button, a self-service environment platform that would empower developers to bring up an environment when they wanted it, wherever they wanted it. And the key part, as I've been repeating, was self-service. And to be able to do that, we had to go ahead and automate these three processes: provisioning of the machines, building of the code, and deployment of the services that were built from that code onto those environments without any human involvement and in one single process. It's not that we did not have automation around these processes. However, there was no one single process that would allow developers to go and say, hey, I want an environment, and all these would happen, and the environment would be there. Each of these was done by some human being handling a ticket and passed on. And that was the challenge. So in 2013, we took on the challenge of proving this concept that we could bring that complex source ecosystem up and running in that one single process and provision it automatically for our developers. And now I would like to invite Vijay, who has been a lead developer on this platform, to help us walk through these phases of our cycle.
Thanks, Varun. Like Tyson mentioned, our Salesforce environment is a pretty complex ecosystem. Trying to build a platform that provisions such a complex ecosystem straight off the bat was a pretty big ask. So what we decided to do was make some decisions to simplify our scope. Our main objective was to simplify the scope, but at the same time, keep all the requirements of having a self-serve environment in place. Yeah, so the first thing that we decided was we were going to pick the hardest service first and just implement that. So for our proof of concept phase, the environments that we provided had some of the core Salesforce component in them, and just those components there. We picked the most used components, the most complicated ones, and the ones that provided the most functionality. At first glance, it seemed kind of counterintuitive, right? Well, how do you provide test environments that only had a small subset in them? But unlike traditional test environments, the environments that we were trying to provide were tailor-made specifically for individual users and groups. So as long as we met the requirements of that specific group, our environments were feasible for them. The second decision that we made was the services that we did provide were going to be exact production replicas or as close to production as we could get. Obviously, we started small. The scale of the services was not going to be similar to production, but the profiles and the settings they used were exactly the production settings and production profiles that these services had in production. So this ended out to be a really good decision that we made, because anytime we approached a team or a user to try out our proof of concept product, they were more than happy to try it out, because the service that we provided gave them a much closer representation of production than most of the test environments that were available to them. So they were more than happy to work with us, even through our proof of concept stage, where there were some glitches during the implementation. So the product that we delivered at the end of the phase looked something like this. It was really simple, right? There was nothing fancy about it. Most of the work that we did during the phase was trying to figure out how can we set up this entire Salesforce components on the fly. When we look at the service itself, it was nothing fancy. It was a basic monolithic app running on a web server. It exposed a few servlets for the users to trigger processes through. Anytime a user would trigger a process, we'd just go get a predefined set of machines, procure them, and download these applications one at a time, deploy them, configure them, start them up. And once this entire environment came up, we would hand it over to the user. The process was very sequential. It took the entire process about 2 hours to finish. And if a user needed another environment, we'd go through the entire process again. Not the most efficient thing. But for the proof of concept, it was really what we were looking for. We wanted something really simple that we can show. We can provision this thing on the fly. And it also allowed us to learn some valuable lessons that we could build on later.
So what did we learn from our proof of concept? Now, this was a proof of concept where we did have some users using the system. And one of the key things we learned was don't repeat the static steps. As you heard Vijay mention, we were taking 2 hours to build an environment. While that was great from several days, so that it took when none of this was automated, 2 hours was still long. And we had to bring that down. We had to try and can these steps into a base image from where we could start building an environment in a much shorter time. We also realized, finally, that we were dealing with humans, and humans are forgetful. So even though we gave people an ability to spawn an environment and terminate that environment once they were done, not many people were terminating their environments. So we had to figure out a way to automatically claim these unused resources to make sure our platform was efficient. And we also looked at the components that we were bringing up. And as you saw, the Salesforce ecosystem is a complex ecosystem. However, the developers did not need each of those components represented in the environment to complete their test. They wanted some core components that would satisfy 80% of their requirements and would allow them to run their test and get the results they wanted. And that's something we took home, and that we focused on those core components to provide the value for 80% of the use cases. That's what led to 2014, where we started working on our initial launch and the initial version of the service, which we would then go ahead and release to the overall organization.
So after the proof of concept, we noticed there were two main areas that we needed to focus on before we could actually launch our application to any reasonable set of users. The first thing was our deployment service. As we mentioned, we took a more traditional approach for our first proof of concept. Like any traditional environment, we said, okay, when we bring up these environments, we're going to download the applications and deploy them on those environments, which seemed like a reasonable thing to do, but we noticed really fast that we were not building a few environments. We were building multiple environments throughout the day, and sometimes the user were requesting the same environment for different testing purposes. And we noticed that we were constantly deploying the same applications again and again. It turned out to be very inefficient. So what we decided to do was, why not pre-deploy these applications beforehand and save them as snapshots? This not only reduced our provisioning time, but it also made our system a lot more stable. What happened was, during procurement now, we never had to deal with any of the deployment problems that we had to deal with earlier. We could just do this beforehand, save them as snapshots, tag them with the proper versions, and once we were procuring the machines, all we had to do was attach them. So this is how we ended up implementing it. Now we had a deployment service that was in charge just for deployments. There was a scheduler that kicks off these deployment services every few hours. The deployment service would then go to the package store, look for any new packages that have been released since the last time it ran. It would then download these packages into virtual machines and start the deployment process. Once the deployment process was done, we would snapshot the entire drive, tag them with the version of the application, and save them. So this actually enabled us to horizontally scale our deployment process. So now instead of deploying one application at a time, we would just download all the applications that were released at single go, snapshot the entire thing, and be done with it. This allowed us to support a lot more versions of different applications than we could initially do on our POC phase. Not only that, now the procurement process was like really simple, right? All we did when a user requested a new environment was to provision the machines. After that, it was just a matter of searching for these snapshots that we wanted to attach to the machines, attach them, start them up, and hand them over. The next thing we wanted to deal with was our resource cleanup first. So like Varun mentioned, for the first phase, we relied on our users to let us know when they were done with a particular environment, which made sense because they had the most relevant information of when they were done with their testing environment. But the problem was, a lot of times our engineers were pretty busy with other tasks that they had to go do after their testing stuff. So they sometimes forgot to notify us about these resources. And we found a lot of these resources were running constantly and occurring costs when they didn't have to. So we wanted to make sure that we proactively cleaned these things up before we released it to a larger number of users. The system that we built looked something like this. We again made use of Amazon's tagging service to implement it. Now, anytime we procured a resource, the procurement service would immediately tag these resources with an expiration date. The expiration date was calculated based on some heuristics we had in our application, which gave us a rough estimate of how long we expected a particular resource to be used by certain users. So as soon as we created these resources, we would tag them with the expiration date. And our resource management system would actively monitor every single running instance that our users had created. It would make sure that none of these resources have been expired. If they had expired, we would immediately notify the user and let him know that an environment that he had created was running past the expiration date that we had initially estimated. The user is given a chance to clean up the resource if he wanted to. If not, we go and proactively clean it up. This made our system much more efficient. With these two enhancements in place, our system was much more stable and efficient than our proof of concept phase, and we were ready to launch our application for a limited set of users.
So, launch day, exciting times. We wanted to release the service to our developers. However, we also wanted to make sure that we were building the right thing. So we onboarded users in a controlled manner. We released it to a limited set of users. We also released the system with one template. Now, template here refers to a setup which allows users to tell us what do they want in an environment, what kind of configurations, what services, how the services need to be set up, how many servers per service, and those type of information. We knew we were going with a simple approach, but we wanted to make sure the first launch was serving the needs of 80% of those users who we were onboarding. And, of course, we had the resource cleanup part to make sure we were always efficient. What did we achieve at 2014? Well, if you remember, our response times at POC were 2 hours. With the enhancements around deployment that Vijay talked about, we were able to bring those response times down to 30 minutes, irrespective of the size of the lab. And we were efficiently claiming back our unused resources. However, there was still a lot of things to learn. One of the key aspects we realized was, even though the service was efficient from our perspective, we had quite a few failures. Our failure rate for a lab request was 10%, and we had to bring that down. We would have to figure out how are we going to reduce the amount of failures that we are sending back to the users. We also realized that we had transitioned developers from being able to use persisted environments, which took time to bring back to a known good state, to a setup where they were using transient environments. And these transient environments were stateless. The data that they would have there would disappear. And apparently, data was as important as code. The developers wanted their data to be persisted so that they could use it in these transient environments when they wanted to test something. So we had to figure out a solution to provide that ability. As well as this was very knowingly one size does not fit all approach, which came about from our single template release. We did know this, but it became very apparent as soon as we released it and every developer wanted to start tweaking things on the platform to get it set up to their needs. For example, our search team wanted 10 searchers, but they didn't care about the application servers, while the team testing the application and the features wanted more application servers, and they didn't really care about the searchers. So we had to figure out a way to allow users to be able to configure faster than we had imagined. And then lastly, while this was great, the ability to request an environment in one process was awesome. They could self-service their environment needs. Developers wanted even more. They didn't just want to go and manually ask for an environment. They wanted to be able to build integrations on top of this platform. They wanted to be able to build their systems, which would automatically go and request environments, figure out what environments they could use, share those environments with other users, complete tests, shut down, publish the results, and be done without the developer having to come back from their coffee break. So that's what led to our 2015 mission, which was transitioning this system into a true platform.
So the main goal here was to see what we can do to our service to make sure it's a full-fledged platform that most of the development teams and users would use. So we went and spoke to most of the teams that used our stuff on the initial launch and figured out the areas that we needed to concentrate on, and that's what we worked on this phase. The first area was, like Varun mentioned, our integration layer. For the first 2 phases, we concentrated on making our service more stable and more efficient, but the integration was lacking. There was a few servlets that they could use to talk to us with, but there was nothing that they could actually really write some integration applications to ease their work. So we went about building a full-fledged REST API platform. The 2 main goals that we had was it should be really easy for users to integrate with us, and it should be easy to manage the environments once they had created it. So the API did some really cool things. First thing, it allowed the users to now pick and choose the kind of environments that they wanted. We allow developers to manage the size of their environments now. So if a user wanted to do some very small functional testing and he needed like just a machine or two, you could now pick the templates that allowed them to create these kind of environments. If a team wanted to do a full-fledged production or performance testing, now they could create environments that were like hundreds of machines bigger. Then we allowed self-discovery of applications that we supported. Now the APIs could the engineers could use the APIs to figure out what applications we supported, and not only the applications, but the current active versions of the applications we supported. Once this was done, they could easily pick and choose the applications that they wanted on the environment and add it onto it. Finally, we completely moved the environment management from our side over to the users, and now they could share their environments with other engineers that they wanted to. They could manage how long their environments lasted for, and other management starts just through our API without interacting with us. The second major area that we were requested on was to provide persistence. Unlike traditional environments, the environments that we provided were ephemeral in nature. So a developer would create an environment, do his testing, and then we would go and clean this thing up, which worked great for a lot of areas. But one area that was lacking was the data that the engineers were creating in them. In some cases, they did want these data to persist so they could reuse in their future tests. One of the problems we ran into here were we noticed that engineers had multiple environments running concurrently, and these environments would have conflicting data persistence needs. So we came up with the concept of gold environments. The gold environments were like a hybrid approach. They were similar to traditional test environments in the fact there was only one gold environment per kind of persistence we allowed, but they were still ephemeral in nature because they only lasted during the day. The developers could ask for limited access to these environments, and once these environments access were given to them, they could add the data they want persisted onto these environments. At the end of the day, what we do is we go through all our gold environments that we had currently running. We'd snapshot all the data drives, save them, and use them going forward, so all the data that the users have saved were available for them going forward. Finally, we had to fix our error handling. For the first two phases, we took a fail-fast approach, meaning anytime we saw any kind of errors, we would move the burden away from the system and onto the users and ask them to retry again, which worked fine for smaller test environments. We didn't see that many error failures, and the ones that did happen, the users were more than happy to just retry again. But once we allowed them to integrate automatically with our API, and we were providing large-scale environments, this was no longer scalable. So we went about fixing the error handling in our applications. We obviously turned on auto retries, so all non-user errors were automatically retried now. We did enable retry throttling and exponential backoff so we wouldn't flood AWS. But most of the work we did was in implementing custom retry paths. We took a look at our application and figured out what the critical points of failures were. And we made sure we had retry paths for every single failure that our system could possibly have, so we could see if there's any way we could make sure we could take the onus from the users back onto our system. Some of the things were, like for example, if an instance wasn't available in a particular AZ, our system was smart enough to actually go check the other AZs, see if these instances were available, and use them. Or we even had logic where users could specify similar instances types that they could use if a particular instance was not available. With these three enhancements in our phase, our service we were ready to distribute our service to a much broader audience. And this is how it looked at the end of this phase. We had a full-fledged API layer taking requests from automated clients and users. The API layer would then process these requests, figure out what kind of environment a user is requesting, and create a model JSON template that we could then pass on to the systems down the chain. The JSON template was first passed to the procurement service, which would procure the machines needed for the environment. Once these machines were procured, the information about these instances was added back onto the JSON template and passed on to the content management service. The content management service would then search for all the snapshots that this environment needed, both data and application, attach it to the proper machines, and send it over the configuration service. The configuration service would configure each individual application, do all the necessary interdependencies that we had to handle, and start them up. It was a much more stable environment, and we were able to release it to a reasonable number of teams.
So what did we achieve in 2015? Well, 2015 was a great year for us. Our usage grew from over 10,000 VMRs on the platform in 2014 to what now is 500,000 VMRs per month in 2016, and most of that growth happened during the year of 2015 when we released the platform version of the product. And a big part of that came from automated integrations. The exponential growth was coming from people building on top of our platform integration that allowed them to automate their test runs. We also reduced our failure rates due to the things that Vijay mentioned around customized retry paths and exponential backups. We were able to reduce our failure rate from 10% to 3%. We also gave ability for users to request a customized template for what they wanted in the setup. We were able to have a turnaround time of a day on those templates, and then that template could be used for months to bring up environments and run tests. And we created 10+ data persistence environments which could be used to create data and persist it for future use in transient environments that the developers would bring up. This empowered the developers to not only have tests which were one time, it empowered them to create multiple tests which would run regressions, which would be able to take a known good state of not just the code, but the data, and do comparisons and run several tests in parallel and enable a lot of efficiency for the teams for their work that they were doing to sign off on their feature builds. However, we were still learning. We realized that we were still doing some steps in a serial manner. And this was internal to our architecture. We were creating snapshots in a serial manner when we could actually do that in parallel. We could take all the applications. The underlying AWS platform allowed us enough flexibility to go and spawn as many machines as possible as we wanted to create multiple snapshots at the same time. And we had to use it. And as the usage was growing, we started also seeing some constraints on certain resources which started becoming bottleneck. Some resources would take longer to come up. So we had to come up with a strategy that these resources don't start becoming a bottleneck, and create a pool of these pre-set up resources that we could inject in an environment when a developer requested that environment versus the developers having to wait for that resource to come up. As well as some of these resources were scarce. We started hitting some capacity limits, and we had to figure out a way to handle that. Lastly, the increase in the usage of the system started showing us the limitations of our POC design. We had set up a single region, we had set up a single AZ. While we had started working on a future design for multiple AZ setup, we really had to accelerate that given how the usage was accelerating off the platform. So that's what this year has been. It has been about scaling our product for the growth that we are seeing, not just to the 500K hours per month on the platform, but trying to get it to support the potential 5 million hours on the platform per month.
So releasing our platform was very well received. We were getting so many requests, we actually had to turn away some teams that we couldn't support them because of some capacity constraints that we had. So we took a look and said, how can we scale our system further and not only handle it for the traffic that we were expecting for the current years, but even do like a really good estimate of the future and make sure that we scale to support those growth as well. So we actually took a step back, looked at our entire picture and said, okay, what can we do to make sure that we fix the capacity issues that we had? So what we noticed was, even though the services that we had designed were like distributed, our platform on its own wasn't really distributed. It was a single platform that was running in one region. So that was our biggest bottleneck that we had. So we started the process that would actually help us grow better. What we ended up doing was we ended up splitting our platform into like smaller clusters. So we could bring up these clusters at any point that we wanted to. They were completely independent from each other. They had their own set of services and databases. We could bring each one and bring them down if we wanted to. What this allowed us to do was it actually allowed us to do staggered deploys. We could now deploy individual clusters, and whenever we had a major release, we could just push those releases into that smaller clusters, have a small set of beta users test it, and then release it to the other clusters. It also helps us increase our capacity. Now, when we were running out of capacity in a particular region, we could easily bring up a cluster in another region where we had capacity and direct our users over there. It also helped us make use of the expanded feature sets. For example, if a particular region allowed a particular instance that our user wanted, we could now easily bring up these clusters on those regions and get this feature to our user faster. So once our service was distributed, we needed some kind of a user management layer that acted as an orchestrator, so the user doesn't really have to worry about which cluster he had to interact with to get his environment. So we ended up building that service first. The user management layer not only acted as an orchestrator, but it actually allowed us to do some granular access to our users. Since we were giving extremely large environments as self-serve environment, we needed to have some way of controlling which users got access to these environments and which users didn't. So we added those functionality into our user management layer too. The user management layer now allowed us to control access to certain teams to specific regions. Now, if we had a limited capacity of certain instances that we wanted to guarantee to a particular customer, we could now have our users directed to that particular region based on their request and their teams. Finally, we worked on a pooling resource. When we looked at our system, we found that our system depended on some critical resources that would fail every once in a while, and this causes some bottleneck on our service. So we ended up building a service that would allow us to store these resources ahead of time. Our main goal here was that we wanted to make sure it was really flexible. The resources that we were having problems with were always transient in nature. We would have a particular issue with an F5 for a week, and then the next week it would be some other instance that was completely different. So we made sure we could pool any instance that we wanted at any given time that we wanted to. We could immediately flip a switch that would allow us to pool these resources, make sure that they're available, and thus guaranteeing that these extremely large environments that were coming up weren't failing because of these few critical resources. With these three things in place, our platform was now much more scalable than what it was. And this is how it currently looks. We have individual clusters that we deploy in multiple regions, and in some regions we even have multiple clusters deployed. Each of these clusters, again, had their own services with their own databases that were independent of each other. We could bring down clusters if we needed capacity, and if we wanted some extra capacity, we could bring them up really easily. And now we have an orchestration layer that took care of customer management and orchestrating these services to orchestrating these requests to particular regions and clusters that we wanted to. Again, we're really happy with where we are, and we're really excited to see where we're going in the future.
So what is in our future? Well, we have created a great platform for our users. We have given them an ability to self-serve their environment needs at different levels. We have given them an ability to integrate programmatically with a system that gives them access to a lot of environments in parallel that they can use without having to wait in line. Where do we go from here? Well, we want to do better than 30 minutes for an environment. We want to be able to predict when is a high traffic situation when developers are requesting environments and pool these environments, plan ahead, and give an environment instantly whenever a developer requests an environment so that they don't have to wait half an hour. They don't have to query the system to get status of an environment. We also want them to be able to customize on demand. Well, while the one-day turnaround time is great, developers do want to be able to change configurations on the fly. They want to be able to change the makeup of their system when they're trying to run their tests right at that moment. We have to build some ways, some functionality that users can use to configure their environment and press a button and or an API call and say, give me this setup, that's what I want now, versus something that was pre-set up. And lastly, we have been very focused on building features that allows developers to use our setup. However, we also want to be able to show them the usage of the system that is coming from these developers. We want each developer to be able to look into how they're using the environments, whether it's from cost basis or efficiency basis, whether they're actually utilizing the machines that they're working with, and how much of that they're using over a period of time. And that's where we are headed over the next years. Now, I would like to invite Tyson back to talk us through some of the key takeaways of this journey.
Thank you, Varun. Thank you, Vijay. So, what did we learn today? So I call this section Camp Takeaway. Oops. Whoa. There we go. So the first thing that we learned was, really know your customer. And what that means is, you could sit here and try to find the best solution to a problem that you think you have, and you think your customers might like it. But if you don't actually spend the time with your customers, really digging into what those pain points are, what is going to help them, you could really come up with a solution that's just not going to be usable. It's just not going to have the adoption and the impact that you want it to have. So really, a key takeaway is get to know your customer really well. The next thing is self-service. We figured out very early on in this project that in order for us to be able to scale at the need of supporting thousands of developers, we would have to make this service as self-service possible. And driving that improvement right out of the gate really helped us scale. We couldn't just continue to throw bodies of developers from our side to build the support into the product. We really needed to have the product be able to support itself. Resources aren't limited. There was a great talk earlier this week that AWS did about getting the best bang for your buck. And one of the big talking points that they mentioned in here was, turn down what's not being used. And again, we also learned very early on that just leaving that into your customer or into your user base to determine how long they need a resource might not be the most efficient or cost-effective way to do it. And so we took a lot of time in figuring out how do we have a system that can actually go through, track, and manage these services so that they could be turned down automatically when they were not in use. Health-mediated services. You heard a lot of talk about, how does this service really going to remediate itself during its life cycle? And again, we knew early on that we would not be able to just continue to throw support heads at, working through and maintaining the system in order to meet the customer demand. We needed a system and a service that could actually mediate itself when it found errors. And so we spent a lot of time going through all of the different error paths that could be generated and ensured that it had the intelligence to actually remediate itself through those errors. If a new error would come up, that was a ticket on our team so that we could actually ensure that we would never see that error fail again where we would have to go in and manually touch it. We would want the system to do it automatically. So driving that into your POC and then ultimately your service going forward really will enable you to drastically grow and scale as adoption as adoption grows. The last thing is track your adoption rate. And I initially wanted to call this section Camp Metrics because for us, being able to track a metric that shows the success of what you're doing is really valuable to know that you're having the right impact on your customer base. And for us, we boiled that down to adoption rate. Now, adoption rate can be broken down into a few other components. which really ultimately speaks to usability, scalability, and availability. But so for us, adoption rate was really, really key to know that we were hitting the right areas. So when we were seeing this huge growth of hours from 10,000 to now over 500,000 hours a month, we knew that we were doing the right things because of that user growth. And so with that, I want to thank you for all joining us today. I want to remind you to remember to complete your evaluations. And myself, Varun, and Vijay will be available here afterwards for Q&A. Thank you very much.